So we're going to use a calculator sometimes because I don't know about you, but I don't know anything that multiplies by itself 5 times to make 9. You know, if I don't start talking about decimals. You can see what the answer is over here. I don't know that. So the way I get my calculator to tell me that is I use the caret key right here. The caret key. And I press that, but I have to use parentheses because if I just say 9 caret 1 divided by 5, it's going to think I mean 9 to the 1, and then I'll divide 9, because 9 to the 1 is 9. I'll divide the 9 by 5, but I don't mean that. I mean 9 to the 1 over 5, because I know that, well, for one thing, here it is. It's 1 over 5. And here it's 3 over 8, so I'm going to say 12 to the 3 divided by 8, because every fraction is a division problem. That's why I'm saying divide, in case you were curious about that. But down here, it might be helpful to convert it to what it really is first. I know that the number out in front, this number, the index on the radical, is going to be the number on the bottom. Now, they printed this in a print shop, and what they really mean is 3 over 4. Sometimes when they print it linearly, it's hard to tell. I don't know. You can tell what's on the bottom, right? The 4 is on the bottom, so that's the number on the index, and vice versa. If it's on the index out here in front on the corner, then the 4 has to be on the bottom, and the 3 is on top. Okay, so we say 7 caret parentheses 3 divided by 4. That means 3 over 4. And we hit enter, and they give us 4 point, yeah, that stuff. Okay, so now we're going to do that with our calculator. I'm going to type in 1695, and I'm going to use my caret key with, what is this? Well, I better translate it first, just to make sure I got this. I'm going to say, this is a 1, right? I mean, it's not there, but it's 1, and it's over 7. The 7 is the index number. So I'm going to say, to the 1 over 7. So on my calculator I have a 1 over x button. That's what I'm going to use, and I raise it to that, and it turns out that it's 2.89274. I guess we'll just go for broke and write all of it down. I wrote down 5 places. Feel free to stop after 4. And then, you know what, I ought to raise that to 7 just to see if I actually get back to that. So I'm raising that to 7, and what do you know, I get back to where I started from. I should be able to do that, right? Okay, so here we go. I have 25. I don't have to translate that, do I? I'm just going to type it in that way. I mean, if I wanted to, I could say, I know this means 25 to the positive 1/3 on the bottom. I know that's what that means, so I guess I could do that. But I'm just going to go ahead and say 25 to the negative 3 over 1 over 3. And so I raise it to that, and I get 0. Of course, I'm going to get less than 1 because it's underneath 1. 3, 4, 2, and that seems to be the end of it. I could put it 0, but I think I'm going to just stop there because it seems to be a rational number. If it stops, this one appears to be irrational. I think it goes on for quite a while. I might be wrong about that, but there's no indication that it stops. Now, there might be a pattern that develops, but anyway, this one appears to just stop. That's a terminal decimal number, and therefore it is rational. So it doesn't matter. These are our results here. Oh, round to 2 decimal places. Wow, it's good to read directions. You know that? It's outstanding if these, if you read directions, that's even better in your life, Even better if you see what they ask you. Yes. Okay, so let's solve equations using the n roots. This is 1 and 2 combined here. You can see that they move the 4. Well, you can't tell, but you can tell. They divided both sides by 4. All right. And then they said, oh, let's take the square root. Let's take the 5th root of both sides. Can't see that now for the trees. Take the 5th root of both sides. Okay. And we're done. And you remember when it's an odd index, when it's an odd root, we just get a positive answer. Okay? Now, this time down here, I'm going to take the fourth root of both sides. And so I'm going to have to think about plus or minus. You can see they say plus or minus. And, you know, I guess if I use my calculator to find the square root of 21, the square root, the fourth root, sorry. So how would I find that? Well, I would say 21, just like I did up there, 21 to the 1/4 power, right? Okay. And then I'd do it again, and I'd say, and I'd add 3 to that. And over here I'd say negative 21 to the 1/4 power, which means I'm going to do this first, and then it's going to be negative. And then plus 3. So they get a couple answers. That's nice. Okay. So let's see what we need to do. Solve this equation and show the intermediate step. Okay, well, I don't really mean this is the intermediate step, but I'm going to divide both sides by 5. So 1080 divided by 5 is 216. And then I want you to show me the intermediate step where you take the third root of both sides. I want to see that. Sorry, crazy like that. Now I think I know what the third root of 216 is, but just in case, let's just say I'm wrong. I'm going to say 216 to the 1/3, right? Because it's 1 in here. And when I do that on my calculator, when I raise it to the 1/3 power, I get 6. X is equal to 6. I kind of thought so. 6 times 6 is 36, times 6 is 216. It's not too big to kind of know after a while.